Hello class, welcome to another lesson. Today's learning goal is I can use power of a power property to simplify expressions. Please write this at the top of the page. I know there's no specific place labeled for you to write down the learning goal, but please write it at the top where there is empty space, as just like up here in your notes. Okay. Today we're going to be learning about how to simplify expressions that have already been taken to a power. So for example, 5 to the third to the second power. It's being taken to a power a second time, specifically to the second power. So what we first do is expand out the expression. We take a look at this right here, to the second power. That means that anything that's in here is being multiplied by itself twice. So that is 5 to the third times 5 to the third. Over here, we're going to spread it out so that we can see exactly what is going on inside that. So we're going to expand 5 to the third in both of these factors. So it's 5 times 5 times 5 times 5 times 5 times 5. And as we know, we can get rid of those parentheses because it doesn't matter which 5 gets multiplied first. And which ones get second, third, fourth, and fifth, etc. As long as it's just simply multiplication, we can do it in any order that we would like. So that means that we have 6 factors, 6 things that are being multiplied by itself. So that is 5 to the 6th. Okay. So similarly, negative 6 squared to the 4th power. That means that's negative 6 squared multiplied by itself 4 times. Expand it out, it looks like this. And expand it out again, we can expand out the 6 squared each time. That is negative 6 times 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 negative 6, 8 times, okay? Which means we have 8 factors, and that is negative 6 to the 8th. Notice that this is in parentheses. That's very important because negative 6 is being multiplied over and over again, not 6 being multiplied over and over again with a negative. Okay? Negative 6 is being multiplied over and over again. If we were to use variables, it would be a very similar thing. Instead of some number, it's a to the third being multiplied by itself 3 times over. That gives a to the third times a to the third times a to the third, which is 9 a's in a row, which gets us 9 factors, a to the 9th. Now, I would like you guys to try to find the pattern. What do you think the pattern is that is going on every single time that we do this? Okay. Please write that down in your notes before we take a look at this. You can hit pause on the video if you would like. What you should have observed was that the product of both of the exponents ends up being our final exponent. So we have the final exponent in the product is the product of the original exponent. So 3 times 2, that's the exponents here. That gets us our 5 to the 6th. Notice how the base stays the same because it's 1 base. 2 to the 4, 2 times 4 is 8. 3 times 3 is 9. So, in order for us to simplify something that's already taken to a power, when it's taken to a power a second time, is that we have to keep the base and multiply the exponents. So again, we have 3 to the 4th to the second power. That is going to be 3 to the 4 times 2, which gets us our 3 to the 8. If we were to use algebraic expressions, a to the m to the n power is a to the m times n power. So, take a look at the bottom part of this. Again, we're going to learn about the long way and short way of doing it like we just did in the previous one. So, this is 5 squared to the third. That's going to take us... Ooh, that's a great noise. To 5 squared times 5 squared times 5 squared, because we're taking 5 squared to the third power, meaning we're multiplying by itself 3 times over. We expand 5 squared, we get 5 times 5 times 5 times 5 times 5 times 5. But the easier way to do it is just simply looking at the exponents. This is 5 to the 2 times 3, gives us 5 to the 6. Fill out this section on your own. Hit pause on the video and try to fill that one out on your own. here, we have something very similar. We expand it to n to the 7th times n to the 7th, because n to the 7th squared is n to the 7th times by itself. We get 7 n's, a lot of n's. Excuse me, 14 n's. A better way to do it is n to the 7th times 2 power, which is n to the 14th power. Okay. Try the next couple of expressions on your own. What you should have gotten is p to the 12th, because 3 times 4 is 12. Over here, we have 3/4 to the 5th to the 3rd, which should have been 3/4 to the 15th. 2a to the 5th to the 3rd should be 2a to the 15th. In our next lesson, we're going to learn how to simplify this even further. There's a way, because there's 2 factors inside this parentheses, 2 times a, 2 and a are factors. In our next lesson, we're going to learn how to simplify this even more, because when we have something in parentheses that has 2 factors, we can simplify it even more. Same thing right here. When we have a fraction inside there, we can simplify that even more, but for right now, this is sufficient. Take a look at the next page. So, this one right here, we have 3 to the 4th to the 2nd power. Again, we're going to multiply those together. We get 3 to the 8th. 4 times 2 is 8. Over here we have 2 to the, over 7 to the 6th to the 4th power. Again, we multiply those together, the 6 and the 4. We get 2/7 to the 24th. And 2a to the 5th to the 3rd, 2a to the 15th. Just because we have a negative symbol inside of here, doesn't really change things. We can still do negative x to the 4th to the 3rd to get negative x to the 12th. That's not how I want it. Okay. Try these on your own, and we'll come back and make observations. As you try them out, you should get 5 to the 12th power, 2.3 to the 8th power, 3p to the 20th power, and over here again 3p to the 20th power, since those are the same questions. But please notice that 3p is in parentheses because 3 and p are being multiplied by themselves over again 20 times. Simplify the following expressions. Okay. Here we're going to use our product property to combine these two. Okay. That is negative 4 to the 2nd times negative 4 to the 3rd, which gets us negative 4 to the 5th. Now we're going to use our power of product property to simplify this part right here, which becomes 5 times 6, which is negative 4 to the 30th power. Okay. Same thing over here, we're going to combine these two. We're using our product property, m to the 6th, and then we're going to take 6 times 3 using our product property, power of a product property, to get us m to the 18th. Similarly, we're combining over here, 6 to the 4th, 6 to the 3rd gets us 6 to the 7th, to the 4th power, 7 times 4 is 28, 6 to the 28th, and in the denominator, we get 6 to the 3rd, to the 5th gets us, 6 to the 2nd to the 5th gets us 6 to the 10th. Now, we have 28 6 at the top and 10 sixes at the bottom. We can use our quotient property. That means we're going to subtract the exponent at the top by the exponent to the bottom. That's 28 minus 10, which is 6 to the 18th. Over here, this is something that we haven't quite talked a whole lot about, but when we have exponents like this separated by a divide sign, okay, yes, exponents happen before division, but multiplication and division happen at the same time. But when we do have expressions like this where we have a number and a variable right next to each other, or a variable and variable right next to each other, okay, such as a, b, okay, we treat them as if they were in parentheses. Okay. That's why we can change this into a fraction. A fraction is a lot easier to see and apply our quotient properties and our product properties. So when we do that, we get something like this, and we've combined a to the fourth times a squared to get us a to the sixth. We use our power property to get us a to the 24th, because 6 times 4 is 24. Down here, we have just simply move things down, but we have a to the 24th and a to the 8th, which means that we can use our quotient property. It gives us 24 minus 8, which is 16. So we have learned 3 properties so far. They are the product of powers, they are the quotient of powers, and the powers of powers. Those are the 3 ones that we've learned so far. We will learn another one tomorrow.